Hello 108 students, Mr. McHugh here with you. Welcome back. We're on section 2.3 and we're going to tackle page 2 and we're going to start coming up with a good plan to help us approach solving application problems. Okay, so what's cool is if you have your book with you, if you looked on page 69, you will see these listed here, basically the 6 steps that will help you and a logical sequence to help you solve these application problems and figure out the mystery of what the answer is to the problems. Now, I asked my students, I'm just going to do a little sidebar here, how many students have watched CSI? Most of you probably know that stands for Crime Scene Investigation, and I have many students who like to watch it, or any version of a dozen programs out there now that are equivalent to the same idea. Basically, there's some kind of mystery in the beginning of the show. Unfortunately, somebody dies, and then the rest of the show is a crime scene unit that goes out and they try with detectives and lab work. They try to figure out and the mystery of who died and who did them in, unfortunately. Okay, so I bring this up there because if you watch, they always bring tools. They come in with a van. Here in Garden City I live, we have a CSI van. I've seen it driving around, and they got tape in there, and they got digital cameras, and they measure things, and they take ballistic experts will grab bullets and take them back to the labs, and all that work, and people love that mystery. And so I'm just going to propose to you guys here that for math, you're going to become math scene investigators. You are going to be experts hired to come in and solve the mysteries of the application problems. I would give you a hat with your name on there, and I'd give you a little badge, and I'd give you a t-shirt just like they show on the shows with MSI on it. So I want you to think of being in that mode of, can you solve this mystery of what the answer is to the application problem? You're going to have a toolbox. All your algebra tools that you have are ready to go. Most students are comfortable with that. The hard part is doing the first 3 steps. Okay, and guess what you have to do? Because you're required to do logical, analytical thinking. We don't do much of it. It's a struggle to get these going. However, you got to read the problem 2, 3, maybe 4 times and to try to understand it, and maybe use diagrams, maybe use tables that help you figure out and gather and organize your information. Okay, once you've done that, you've read it a couple times, you know what you're supposed to find, you need to assign it a variable, whether it's the variable x or the variable y, because you're going to write the relationship of an algebraic equation. Key, sometimes you read relationships inside those problems, and the key to these is to let the unknown value that you know the least amount about, the one you know least amount about, be your variable. Okay, I'll explain more about that, but that is a key component to doing these problems. Your goal is to write the algebraic equation. I like to write a strategy equation before I write the actual algebra equation. It's like an intermediate translation step. Remember that translator from the last page. Okay, translate from left to right and use your variables and the equal sign. Number 4, once you've got number 3 done, you got to make sure it's written accurately. If you don't have the correct algebra equation, the rest of this work is meaningless. However, assuming you have the right equation, you solve the equation. Most students are comfortable with that one. That's just like a regular algebra problem. Then you got to be careful. You got to go back and state the answer. Where there are 2 questions to it, where there are 2 parts, you got to make sure you answer the right question, and especially when you put them in MyMathLab. Finally, number 6 is to go check your answer. Make sure it goes back into the original problem and it works out. Okay, so let's try an example here. We've got example 3 on our class notes here. We are given a perimeter problem. So I've got a rectangle going around, and the perimeter of this rectangle is 110 centimeters. Okay, you read the problem. It says L stands for the length of a rectangle is 1 centimeters more than the twice of the width. Now you read that. That's a tongue full of information in one sentence. Now you got to go back and break this down and dissect it. What do you know the least amount about? Between the length and the width, what do you know the least amount about? Okay. Now, what do you know about the length? Oh, if there's a relationship, it's what? 1 centimeter more than twice the width. So you know something about the length. Do you know anything about the width? Any relationship with it? And the answer is no. That is going to be your variable. You're going to let W be the width, and we are going to write length relative to that width. Okay, so you're part into dissecting it. Next step here, I have step 3. We have a formula. Now, in your MSI toolbox, you know that the perimeter of a rectangle is 2 times the length plus 2 times the width. Okay, that's where you get paid the big bucks. You've got the tools that allow you to go through the analytical, logical reasoning to solve these. Okay, now 2 times the length. Oh, but what's the length? We have no number given to us. All we know is the perimeter is 110 centimeters. Don't know anything about the length except what? It is 1 centimeter more than twice the width. 1 centimeter more than twice the width. Does this algebraic expression represent the length? So think about that. 1 more, that means addition, 2 times the width. Now I wrote it 2W plus 1. Could I have written 1 plus 2W? Hopefully you said yes, because addition is commutative. The order does not matter. Okay, so instead of putting length, you're going to substitute 2 times the width plus 1. Now here's your W. And now that you've got an equation with one variable, 110 centimeters given for the perimeter, 2 times 2W plus 1, that's representing the length, plus 2 times the width, that's from the original equation, you now can start step 4 and go ahead and isolate and solve for W. Okay, distributive property gives you 4W plus 2. I'm going like this. And I got another 2W, so I've got 4W plus 2W is 6W plus 2 equals 110. Isolate your W, minus 2 on both sides. You get 108 equals 6W. Okay, so this part, from here on down, you're doing pretty good. This part's easy for students. How do you do to isolate the W? Divide by the coefficient of 6 on both sides, and W equals 8. 108 divided by 6 is 8. Okay, that's the width. Remember, you got to label what you solve for. W was equal to the width. How do I figure out the length? Now be careful. In MyMathLab, they will ask you for the length. You've got 8 for the width. You worked hard for it. You put it in there for the length. Guess what you're going to get? X. Wrong. And then you're going to be mad at yourself. And you actually did it right. You just got to remember to take the width. Do what? 2 times the width plus 1. That's all the way up here. So 2 times 8 is what? 36 plus 1 is 37. So your answers are what? Length equals 37 and width equals 18. Put those in the correct order in MyMathLab and you got it. Okay, we are in pretty good shape here. So I'm going to sign off for now, and I will see you for page 3. Okay, bye.